Another topic that's really related to compound interest is effective rate or effective annual yield. You'll see these phrases used interchangeably. And basically the idea here is that if you were to compare a compound interest to a simple interest, what simple interest would you need to get the same amount of money at the end of a year as using that compound interest? Okay, so it's kind of like, instead of going through the work of compounding it over and over again, what if you just did it one time? What would the rate have to be to get the exact same amount of money? And so that's the effective rate. This is a great tool for comparing accounts. If you were to compare two different accounts or two different investments with different interest rates and different compounding periods, you can determine which one is better to use by looking at the effective rate. The effective rate, whichever one has a bigger effective rate, is going to be the better account over time. Okay. So, just as an example, it says here, what is the effective rate of 1.4% annual interest compounded blank? And I've got three options there: monthly, daily, and continuously. Well, to calculate the effective rate, you don't need the principal. The principal is arbitrary here. It could be any amount. It's the rate that's important. You also don't need the time because you're looking for a 1 year period, and so the time is really just one. Okay, so what you're looking at then for the effective rate is the rest of the formula. Take the P out, put a 1 in for T, and that gives you almost your effective rate. So in this case, that multiplier is 1 plus R, which is 0.014 over N. And in our first case here, this is number 1, N is monthly, so that's a 12. Raised to the 12th power, and remember the T is just 1 because we want this over a 1 year period. And so we make that calculation and we get, let's see, parenthesis 1 plus 0.0, 1 over outside again, 0.014 over 12 raised to the 12th power. Okay, 1.01409 . Okay, as an interest rate, you move the decimal 2 places over to get the percentage. But this seems really high. It seems like 101.4% essentially if I move that decimal 2 places to the right to get my percent. And that is kind of high. We're not getting 101% here. Right? A 1.4% does not give us a 101.4% effective yield. What it does do, what we're not accounting for is that this percent includes the original 100% of the principal, which in the end we want to peel off. We don't want to peel that 100% off at the beginning because the 12 needs to apply to it. The power needs to apply to this whole thing, but we peel that 100% off at the end. And so really, if we subtract the 1, which is the original 100% of the principal, then what we get is, got a little bit more horizontal, then what we get is 0.01409, which is, if I move my decimal over, 1.409%. So a 1.4% annual interest compounded monthly gives us a 1.409% effective yield. So it's slightly higher, which it should be because the compounding puts more money in. So the effective yield should always be slightly higher than the original interest rate. Okay, it's really not that much higher in this case, but it is higher. If I wanted to repeat the process for daily compounding, and now I'm going to develop a formula. Let me give you the formula real quick for the effective yield. The effective yield or the effective rate is uses the letter Y to represent it. So this is Y right here. The effective rate or effective yield, annual yield. Those are all interchangeable terms. and it's going to be equal to the 1 plus r over n to the n power. So it's this whole thing without the p and with 1 in for t. And then you subtract off 1 after the fact, okay? And then of course change it to a percentage because that's going to come out as a decimal. And so to do that with our daily compounding, for daily we have the yield is going to be 1 plus 0.014 over 365 raised to the 365 power, and then we subtract off that 1, which represents the original 100% of the principal. Got to go to the calculator on these. Parenthesis 1 plus 0.014 over 365 parenthesis raised to the 365, and then outside of the exponent minus 1, and that gives us, oh, I should do an approximate here because it's not, I'm going to have to round it. It's 0.14, I guess 10 if I rounded it to the nearest 10,000 there. 10,000, 10,000, yeah. Because it's really an 0.98 and then some other stuff, but it rounds up to a 10 there. So, which is equivalent to 14.1%. Okay, so that's the effective yield. So it went up a little bit, right, from 0.09 to 0.1. And of course, if I went to continuous, now this one's a little bit sketchy. It's not sketchy in the fact that it isn't accurate, but it's not given. This formula is not actually given in your textbook, the yield for the continuous compounding. But what I'm going to go ahead and do is work with it. And basically it's the e to the r part minus the 1, okay? So it's e to the 0.014 minus 1, and it should work out anyway. E to the 0.014 minus 1, yeah, that works out nicely. Turns out to be, approximately 0.0140984. So it actually went up a hair, but if I round to the same decimal place, it actually doesn't change. It's 0.01410, I guess, again. So it really doesn't change that much. It's very close. It only changes in the 100,000ths and millionths places, way out past the decimal, which is a difference. And over a long period of time, that increase does, it does have more of an effect. And it also has more of an effect if you have a large principal, if you're dealing with hundreds of thousands of dollars rather than, hundreds of dollars or something like that. So, so these differences in the effective yield really do come into play with larger amounts of money, larger interest rates, and larger periods of time. But right now, for what I have, it's effectively, not affecting things very much, at least where I'm rounding them off to. So, but anyway, again, just to reiterate this, if you're comparing interest rates or comparing accounts, which is going to be something in the homework, you just compute the effective yield for both accounts and see which one's bigger. Whichever one's bigger is the one you choose. Okay, so it's that simple. You really don't have to do anything too crazy with those.